third position in the Spark Challenge held at ICIP 2021 and runners-up in IEEE ICAS Grand Challenge 2021. Both are very popular and you can say the renowned conferences we have in the field of image processing and computer vision. He received SAP 2024 award to visit university in UK for neuromorphic models development. He is elected as governing body member Asia Pacific Neural Network Society 2024-2025. His team is appreciated and received 1 lakh cash prize money for successfully design and implementing STA, that is see-through armor for Indian tanks by Indian Army. His research interests include video processing, image processing, medical image processing, underwater imaging, machine learning, pattern recognition, neuromorphic models, remote sensing, image analysis. He has published more than 100 articles in reputed journals and conferences. He is a senior member of IEEE and life member of Indian Unit of Pattern Recognition and AI. So with this introduction, now I would like to request Professor Badri sir to kindly start the session.
Thanks, Dr. Deepak. So let me share my screen. So may I switch off my video so that I can save some bandwidth?
Yes, sir. Yes.
I hope my screen is visible.
Visible, sir. Visible.
And another point, if I'm changing my slide, my slides are moving, right?
Oh, yes, sir. Now you could see outlines. Yes, you can again the first page. Yes.
Okay. So good evening all, and thanks a lot, Dr. Deepak, for inviting me and giving me an opportunity to share my knowledge. So today talk, I'm going with activity recognition and localization using deep learning. So mainly we worked a lot on this domain for last maybe you can say 10 years, mainly on activity recognition and localization. Mainly it's a component of video surveillance, you can say, or you can say analytics design for many of the computer vision or cameras installed at different places. So today talk, I will be concentrating on most of the work what we have done. One of the project related to MIT mainly. MIT has sponsored this project. And the idea was that to design a smart home application where old age parents or small child are staying inside the home. And due to, you can say, staying alone or maybe affected by some disease, they used to fall down inside the home. And we are aiming at detecting the movement, or you can say detecting the faults, whatever happening inside the home, so that nearby, you can say medical unit or the person who is responsible for attending the patient can be easily tracked down, or you can say informed, so that the proper care can be taken. So this is just, as I mentioned, this is a project from smart home application by MIT, and many institutes are involved in this, and we are part of solving this one using computer vision based approach. And whatever I am presenting today, so activity is related to falls, or you can say a person is falling down. So this is the application, but I am concentrating for today talk. Now, these are the outlines of my presentation. So I'm starting with the concept of activity or falls. So where I'm mainly concentrating what exactly falls is. And again, what are the approaches available till now to detect and predict the faults, and what exactly the approach has a problem or disadvantage, why people went for camera based and why we thought of going for camera based action recognition system, that I will cover in the second part. Then we have developed several approaches on this regard. So we will try to summarize few of the proposed approach for this application. And definitely after that, I'm going for action recognition for dark or low light condition. So many a time you might be knowing that the old people who are staying alone inside the home, they fall down usually night time when they are coming for toilet, or you can say they are going to washroom. So during that time, usually they fell down. So next part, I will be concentrating on how to recognize the activity inside a dark or low light condition rooms, and then conclusions and few references what exactly we have used for this approach. So starting with the concept of falls. So falls usually occur maybe abnormal child or a old age person usually inside the home, or you can say usually a falls of a person happens due to old age or maybe affected by some disease. So if you consider the statistics in India for last 5 years, so you will find that it is the first cause of accidental death, which is mainly due to a person falling inside the home, and third cause of chronic disability, and fifth the most common cause of death anywhere in India. Out of 3%, you will find one person over the age of 65 at least falls once in a year. So you can say clearly that if you are counting the people in India who are old age and staying home alone, 33% of them are high chance that they will fall in home at least once in a year. And those cases, if you consider, out of that, 70% case mostly occur in a home rather than any other place. 70% cases are occur inside the home. And if a person is falling down, there is a high chance that, or there is a phobia that the person will fall down again. And if we can detect and give a proper medical treatment to the person in the first fall, then there is a chance that the person can survive. And this is the motivation behind the complete thing, that as you are aware, many of the old age people, or you can say the small child who are affected by disease, they are staying home alone. And many of the people, or many of us who are working outside, they used to go away from home, leaving them staying alone inside the home. And the problem arises that due to no one is attending them, these people severely affected by falling very frequently. And this is exactly the problem what we want to consider. Now, if you consider this problem, now in market, or you can say what are the devices available in the market as follow. So you might be knowing that many of us are using diabetic testing device, or you can say PPG based sensing smartwatch device people used to wear. Now, what exactly happens? Most of the aging population, we severely maybe affected by diabetes, or maybe you can say old age condition, many people are affected. Now what exactly we used to do is, we used to ask the person to wear a smartwatch or a PPG based device. So what exactly that smartwatch is doing? Usually monitor the heart rate of the person. And similarly, if a person is affected by diabetes, you are using, or we are using several times a smart device where you are using a sensor strip, and we are measuring the diabetes measure and noting down manually. Now case is that most of these devices are not connected with each other, or you can say these vital parameters whatever we are measuring, these are not giving any conclusion over here. All the conclusions are identified by us. In that case, most of the devices or smart care devices, whatever we are using, these are only for measuring parameter. They may not be accurate. And second, also may not be giving any conclusion to us. Then definitely you may need a ambient assisted living system, or you can say a system which will help you at least to identify if the person is affected by any faults or falling down in future. So this is what exactly the problem statement we have drawn from here. Now, when we consider that this is a problem, what are the technology available in the market? So we found that fall detection prediction is one of the basic necessity of care facility, especially for old people and weak, even normal person also. Now, what are the approaches available, we found that there are four type of devices available in the market. So one is social alarm system, second one is floor vibration system, wearable sensor, and camera-based surveillance. So these are the four methods by which people are going to detect the fall of a person. And this is what exactly we are interested for. And that's why we thought of reviewing them one by one. So when we went for what exactly social alarm system is doing and how it is working, the principle is something like this. The person who is a old age or a weak person, they used to wear some kind of devices like this, which is attached with a small switch. Or you can say they have a watch, something looking like this, where the person is wearing this watch on his hand. Now what happens inside this device, there is a small accelerometer sensor is there, which is embedded in a watch or pendant, or you can say belt, or can be clip-on devices, which is wearable in hand. Now what exactly happens if a person is falling down, this accelerometer will try to take a reading of it, and it will send a signal to the main server. And many other devices are coming with a small switch which is attached to this sensor. So either the person who is falling down have to press the switch, or the person is supposed to have a you can say accelerometer inbuilt sensor which is sending a signal to the main server. Now once the person is falling down, the signal given by the device, a customer care executive is supposed to give a call to the person and check if he is in the fine condition or not. If he is not attending the call or not responding properly, then definitely a wearable sensor company will give a call to the nearby either medical center or the person who is responsible for him to attend. So this is what exactly social alarm system is there. But one of the biggest problem is that the person who is falling down, many a time he may not able to press the button. And second thing is that the person who is wearing the device, even the customer care executive will give a call. Maybe a proper correlation between both the person may not be possible to understand what exactly happened. And many a time it may be possible that the person fell down, although the person attended the call, he may not able to explain that whether he fell down and how he fell down and what are the activities happening, whether medical checkup is required or not. Remote position, it is not possible to understand. Then people thought of going for a floor vibration system. So in floor vibration system, it is assumed that in a particular home, the floor is inbuilt is attached with some kind of sensor, or you can say inside the home, all the floors are attached with one kind of accelerometer sensor. And this sensor is responsible for selecting or detecting the vibration sound produced by falling of a person. So you can understand something like this. So every room of the house will be equipped with a accelerometer or vibration sensor, and this sensor is connected to a microphone and controlled by a small controller in the center of the house, where the signal is recorded and applied with some machine learning algorithm to detect what exactly happening inside the room or the person is falling down. Now, if a person is walking, it also produces a vibration. If a person is running also, it is producing a vibration. And if a person is falling down also, this floor is supposed to create a vibration. Now the aim is, or the device aim is that the attached machine learning or AI based software will try to detect what exactly happening and the fall if happens. So it's supposed to be detected by the AI based algorithm. So this is what exactly floor vibration system. But problem is that these type of devices are very costly, or you can say if you want to equip a particular home, it will cost around few lakhs or to few even crore, so that you can cover the complete house, because the vibration sensor, whatever you are fitting, it has a range and also it can accumulate data with a particular radius. So this is was the challenge. Then people thought of going for wearable sensor system. So many of us are aware that in the mid of 2000 to 2020 or 10, people thought of going for a wearable vest where different sensors are equipped to capture the ECG, or you can say EEG data, and to detect the abnormality when there is a chance that a person is supposed to fall down. So idea came is like this. So this is a kind of device what exactly we have developed in our lab actually. So in this device, there is a, you can say, silver coated flexible dry electrode is there, which is a screen printing technology embedded with the actual cloth a person is wearing. So if a person is wearing a cloth, on the screen printing technology, the silver coated flexible dry electrode is embedded with the cloth of the person is wearing. And this dry electrode is mainly responsible for computing the ECG signal what exactly we are using. So the complete diagram of the device is like this. So this is a kind of vest which is attached with a small device or small sensing element attached to it. So this device is composed of one microcontroller mainly embedded with something around, you can understand that 0.1 second for each 10 segment it is sending signal to the main server. So it consists of a Bluetooth module 4.0 mainly, and it has a inbuilt frequency of 2.4 gigahertz with a 0.259 battery. So supposed to work for almost 24 hours, and it has a detachable battery is there. So once every day, once morning time, you can detach it and attach a new battery to it. So while using one battery, other battery you can put it for charge and you can use for second day. So exactly what exactly happens is every day, every 10 seconds, it is sending once the signal to the mobile device which is connected to this mainly Bluetooth module device, what exactly attached to it. Now, initially, when we thought of taking or gathering this ECG data, so we found that initially we tested with a person with a mental stress and normal subjects. So if a person is affected by some kind of mood swing, or you can say having mental stress in their mind. So when we recorded, we found that this is the result what exactly we got. So here you can see that if your consecutive cycles you are taking, they are very close. So this understands that the person is mentally stressed when two of its peak are very close. Whereas if the peaks are very far away from each other, so this is a normal subject you can consider. So this is what exactly initial analysis says, that if a person is affected by mental stress, they fell down. But many times it observed that if a person is in normal subject also, there is a chance that they will fall down. So for further analysis, what exactly we have done is we try to take different other features for our analysis. So starting from PR interval, RR interval, QRS interval, and QT interval. So this represents peak to peak, valley to valley, and diastole and restole distance, whatever you are, systole distance, whatever exactly you are measuring from the ECG signal. So we consider this analysis and we have used it for further representing a person is affected by any disease or not. So this is what exactly we have considered as architecture. So the input signal we consider as a 2D signal and we feed it into a convolutional neural network. So what exactly we are doing is we are using a ResNet 50 architecture where multiple layer of convolution are there and there will be a skip connection from the previous layer so that there will be no gradient die out problem will be there in this architecture. And this is the result what exactly we got. So we got around 90.2 accuracy to detect that if a person is affected by any kind of disease and there is a chance of fall is there. But when we consider this type of device, so we found that one of the biggest challenges is that while monitoring for longer duration, since the vest is attached to the human body, there's a chance that due to sweating or you can say everyday regular activity, these clothes are getting a high chance that it will be affected by dirtiness. And that's why you may need to wash these clothes every day. And for that reason, all the issue arises and people thought that why not try for other approaches? And this is the approach what exactly you will find currently people are using for camera-based surveillance, or you can say activity recognition for camera surveillance. And here the idea is clear. We are detecting the calls from a camera. Now, what exactly this approach is doing? So there is a camera sensor attached to the home of a person, which is recording the gesture of human, or you can say whatever activity is happening in the video scene, it is trying to record them. And this data is sent to a data center, or you can say central repository, where a machine learning or AI based algorithm will be there to predict what kind of human activity is going. And if the person is found to be falling down, the nearest center or nearest healthcare center, or you can say the person who is responsible for it, it will be immediately given an alert so that they can attend them and create whatever activity is required to attend them. Now, while going for this, initially we thought of installing some kind of camera in a place so that proper monitoring can be happened and true or real-time subjects we can capture. For that reason, we approach different old age home in Calcutta. So there are several old age homes are there in Calcutta. So initially we approached a old age home in Calcutta so that we can fit different type of cameras in the rooms, and we monitor specifically the old people where actual subject testing can be possible. Now, while going for this, one of the biggest challenge we got that most of the architecture or most of the algorithm what is available in the literature, these are applicable for small or short duration videos. So where the video is captured for very small duration and testing is happened for detecting the activity for small duration. But while considering the requirement for our case, we found that the case is very different from what exactly reported in the literature. So here, most of the activity or most of the videos what is captured is a very long duration, or you can say these are untrimmed videos. So where several activities are happening throughout the day, and these activity may be similar, there may be different kind of activity, or may be possible that the activity whichever you are considering that may not be available for the complete day. So in that case, training and testing of the models will be quite difficult. And for that reason, we thought of exploring different other way how to test our algorithm. Now, before going to further on this algorithm, let me describe what exactly we are exploring and what we are interested for. So when we are considering any kind of CCTV footage or the recording, whatever we are capturing, so definitely this is a kind of video or videos you can say. And formally, a video is a sequence of image frames and it has two main components. One is spatial coordinate. So when you are saying spatial coordinates, you have a particular image frame is there, or video has one frame is there, which is represented by two-dimensional quantity x and y. So x stands for mainly vertical axis, y stands for horizontal axis as per image processing convention. The third axis we are considering is temporal coordinates, which is mainly representing the frame number or a frame in a video. And if you consider fix the t value, we can consider every time instant is represented in a video by a single frame. Or you can say a video is represented by sequence of image frames where each sequence is represented by different timestamp to represent the temporal axis. Now, what exactly we are interested is, given a video, we need to recognize which action is present on that video. So more or less in a particular video, since we have several segments are there, each segment is composed of a kind of activity. So in that case, our challenge is not only recognizing the action, rather localization of the action. So considering that I have a stream of videos or you can say I have a sequence of frames. I am interested for first recognizing or classifying the action in a video, and second is that localize where exactly this activity is happening. So in other words, we can understand that the complete problem lies in two parts. If you have a video, from which frame to which frame, what kind of activity is happening? And again, we are interested for finding a fall. So that means among this activity, if there is any suspected activity which is mainly responsible for fall, that we need to identify. And this is what exactly we are interested for a complete duration. Now the second challenge what we got is, while considering a sequence of video or frames, or you can say sequence of image frames, many a time it happens that in a particular old age home, there are possibility that multiple people are sharing the same room, or you can say two people are staying inside one room. So two different activities happening. Maybe possible that one person is affected by some disease or chance of falling is there, whereas other person is accurately fine or perfectly fine. So in that case also we need to create an alert and send a information that the person living on that room is affected by some disease. Second thing is that if there is a chance that one person can visit to other room and they may be affected by a disease due to some reason. So two tasks are there: identify the person, send a signal to nearest person or near health center to attend them. So this is a again variation, or you can say complexity of challenge what exactly we are concentrating on. So before going to this, we must understand that what exactly this trimmed and untrimmed video is there. So when we are saying a trimmed video, a particular video sequence or a particular small video contain only one action, or you can say a single stream of video contain only one action. Whereas when we are saying untrimmed video, the complete video is composed of multiple actions. And maybe possible that when we are saying untrimmed, this is a continuous video. So it may not have an ending, it is continuously flowing. And in real-time scenario, we are trying to detect what kind of activities happening in the video. And this is where exactly we are concentrating on. We have multiple actions in a video and we need to categorize each action one after another. And this is exactly an example what I mean by. So you have a video, it has only one activity. So you can see here, the person is surfing inside a sea and the model is supposed to give a single level or single output that this is a surfing person or the person is surfing. Whereas the second case, one video is composed of multiple level or multiple activity. Now you can see here, the person is playing a flute, the girl is drinking a wine, a person is clapping, some person is dancing. These are different activity what is exactly happening in the video. And our case, the challenge is that there are multiple levels are there or multiple activities there. And my aim is to identify each activity. We need to note what kind of activity is happening, which frame to which frame duration. That is 6 a.m. in the morning to 6:15 a.m. in the morning, or maybe possible 8:31 in the morning to 8:32 in the morning, whatever the activity happens. And out of this activity, which activity is exactly all you are interested, where the person, family person, or you can say the nearby medical center is supposed to be going to attend them. So this is the what exactly problem we are interested on. Now, while going for this process, first thing is that we found that you need to have a large amount of data for training the model. And we found that in the literature, although many work has been done for trimmed sequence, untrimmed sequence, there is no work has been done. And when we review the literature, we found that there is a DeepMind kinetic human action video dataset is there with something around a large amount of videos with 400 human action classes has been recorded. And this is available for public use where YouTube videos are taken for each 10-second duration to represent a very big database for video processing. Now, what exactly we populate that? Although this thing is populated, but untrimmed video, they have rarely checked, or you can say they have demonstrated. Further, we found that there are different algorithms, 3D CNN, or you can say PIT-based transformer architecture or cross-attention mechanism. Many algorithms are used for such application. So this is what exactly we observed for trimmed video. Similarly, for untrimmed video, we found that there is a database present, which is called as mainly Thomas 14 dataset. So where some action has been considered or some activity is considered for mainly untrimmed video sequences challenge, where different algorithms starting from you can say attention based or temporal action proposal based architectures are mainly used for classifying of the action. Now, as I mentioned, most of the architecture, since you are using untrimmed video for classification, so what exactly they used to do is they used to train their architecture on a trimmed video, and while testing, they used to test on the untrimmed video, or you can say divide the untrimmed video into small segments and test them in the each one. So this is what exactly most of the architecture concentrated on, and most of the architecture is found to be using this type of model. Now there are several other applications are there other than what exactly I mentioned, that detecting the faults. So this can be used for several other architecture or several other application, starting from the abnormal situation detection, military application where many intrusion happens through the border region. So where many enemy side soldiers, or you can say usually drones, or you can say many animals sent by the other side of the border can be easily detected by camera based devices. Mainly you can say as we have planned it for elder people and kids monitoring system, so we have confined ourselves to only this application where we are detecting any old person or small kid is affected by any falling option. So we are trying to restrict our algorithm for this option. Other than that, as I mentioned, that we are also concentrating on start and end frame of activity or any kind of particular activity we are interested for. That also we are recording so that a person can have a knowledge about what exactly the other person is doing, on which you are monitoring, that throughout the day, how much time he is taking for reading the newspaper, maybe sleeping. So maybe possible that if a person is affected by some kind of disease, maybe this can be one of the way by which you can detect if the person is affected by some kind of disease. So this is another application we thought that we'll explore parallel to it. So this is what exactly we are interested for. Now, one of the biggest challenges are all things supposed to be happening in real time. So when your video frames are coming, at the same time, you have to determine what kind of activity is happening. And second thing that we have to detect that this is the first frame by which the activity started, and this is the last frame by which the same activity is completed. Now we have summarized the problem statement. Although many of the state-of-the-art techniques have considered multi-layer CNN architecture for action localization and recognition, but rarely they consider for untrimmed video or less explored for untrimmed video. And second thing is that we found that most of the existing architecture do not consider the motion information in a video to involve in any kind of architecture. And definitely, as I mentioned, our priority is the real-time scenario. So most of the existing algorithm fail in the real-time scenario where long untrimmed video is there. And fourth one is to concentrate on dark or low light environment condition where performance also affects a lot. So as I mentioned that many of the people who are falling down, they usually fall down during the night time when there is a low light condition is there or very dark environment condition is there. They used to go for washroom or they are inside the toilet. There is a chance that they used to give a fall down inside the hole. So this is what exactly our problem statement we are concentrating on. Now, while going for all these models, we found so the complete architecture, what we exactly, there are two type of architectures are used. One is fully supervised temporal localization. Another one is weakly supervised localization process. So in case of fully supervised temporal action localization model, you need to have frame wise levels, or you can say different frame levels are required to detect in a particular video to represent that this is the activities happening in a particular video. Whereas weakly supervised case, the complete video information is required to represent the level, otherwise not possible. So this is what exactly the complete architecture is considered. So we started with initially a small model. So we are saying C3D or C3D based localization model. So this is what exactly our architecture represents. We consider a particular network to be trained on mainly trimmed videos. So we have taken some kind of trimmed video database. What you understand is what I mentioned previously, the databases. So we consider them to be trained on this architecture. So we thought of train the complete model by a trimmed video dataset, whereas test the algorithm in case of a kind of untrimmed video or the video what exactly we are concentrating. So the trimmed video dataset, whatever we are considering, we are passing it through a C3D model, so which we say a 3D CNN model. Rather, the feature what exactly we are extracting from this C3D model are projected into latent projection layers. So you can understand that the 3D CNN model, whatever exactly we are considering, it is trying to extract the feature from the trim video dataset. And this feature, what exactly we are extracting, we are feeding it to action byte extraction. So we consider that in a complete video, you may find many instances are there which are similarly looking or similar condition. Like a person is eating food, there are different way of eating food. So he may be sitting and eating food. Maybe possible that sometimes he is standing, holding the plate, eating the food. And maybe possible that sometimes he is watching the TV, one hand remote is that, other hand he is eating the food. So this way, we consider these are small action bytes. And we try to get the information that such action bytes, although are similarly not looking, but they are correspond to a particular action. And we cluster them and we assign a pseudo label for them. Further, we apply it to a KNN classifier. So why we are considering KNN classifier is that we found that KNN classifier is one of the algorithm which can be used for real-time operation, or we can say we can easily use them for real-time application. And further, all this complete architecture are trained on two type of cost function. So we are considering classification loss and localization function or loss is the two loss function used for classifying different kind of activity. So for the complete architecture, we are using a pre-trained C3D model to extract all these features, what exactly we are considering. For action byte extraction, we are using time intervals in the appends to latent concept, or you can say in the latent feature space, we are considering different time interval to represent the action bytes. So let me go through the slide so that it will be clear. So we are, as I mentioned, that we are using a 3D CNN model. So if we understand the 3D CNN model, so it's a kind of 3D convolution. applied on a three-dimensional filter, or you can say previously the CNN filter, what we know, it uses only a two-dimensional kernel to pass over a image. Whereas when we are saying 3D CNN, we are applying a 3D kernel over a video to extract the picture out of it. Since we are considering a 3D CNN model, the information what exactly we are getting out of it is the spatial information and the motion information due to optical flow. So these are the two combination of algorithm to represent the C3D picture what we are considering. So this is what exactly feature space we got. So from this feature space, as I mentioned, that the first task is to create the action bytes. So you can see here, similar looking actions or similar looking activities are clustered into similar cluster. Or you can say, if the person is eating food, we are considering all the person whenever different way of eating the food can be considered to be a single class. So that's why we are using a k-mean clustering algorithm to cluster them into one particular classes. Further, what exactly we are doing is we are trying to consider wherever there is a boundary will be there, we are representing these are different activity or these are difference between the features. So for that reason, every time we are comparing the picture extracted from the first frame with the second frame, second with third, third with fourth, and wherever there is a large variation is there, we are saying this is a boundary representing one particular action bytes. Now, if we have multiple action bytes are there, we are clustering them in the k-mean clustering to represent different type of cluster or activity to represent. For the complete model training, as I mentioned, that we are using a K9 algorithm for classification because it's a real-time prune, or you can say it is more important to consider real-time detection of it. So that's why we are using a KNN classifier. And we consider two type of loss function. So one is multiple instance learning loss, another one is coactivity similarity loss. So what exactly we are doing is, first instance, we are considering that there are two bags are there. We are saying it's a positive bag and negative bags. So positive bags respond to a particular activity and negative bags correspond to all other activity. So we are trying to contain different activity as one cost value. And for that reason, we are modeling the complete features into two feature loss function to represent the differentiate, or you can say differentiate between different activity, what is happening in the scene. So this is what exactly we consider. And when we try to test it, so this is the result, what exactly we have got it. So as I mentioned that we have considered Thomas 14 database for training the model. And this is what exactly result we got. The proposed model is giving almost 55.55% accuracy in case of intersection of union accuracy of 0.1. And whereas we are getting 22.54% for 0.5 intersection of union. And when we are considering for mean average precision, we are getting almost 96.10% accuracy. While comparing it with most of the existing state-of-the-art technique, we found that there is an approach called as SSN, which is giving almost 60.3% accuracy for 0.1 intersection of union and 0.5 for 29.1%. So this is what exactly we found. And we found that the proposed approach is although performing good, but not based in case of SSN or as compared to SSN. Now, while going for this, we found that there are challenges due to feature extraction what we are using for 3D CNN model. So for that reason, we have went for a 3D resonate model with localization technique, what we have considered earlier, to represent the complete model. So this is what exactly the second architecture we explored. So what we have considered is, in place of previously whatever exactly we have considered for feature extraction by 3D CNN model, so this time we have considered for ResNext 101 model. So ResNext 101 is a 3D CNN model, which is composed of extracting the feature, both 2D and temporal direction, that is the motion information. And these are projected again to lattice projection layer. And exactly we have considered the same model that we are extracting the action bytes, considering that difference between two frames level information to be compared to group into different action bytes. And exactly we are using KNN algorithm again with a similar type of cost function what we have considered earlier. So there is a particular reason why we have chosen the ResNext 101. So the ResNext 10 model is a kind of ResNet architecture only. So which is substituting 3x3 convolution inside the bottleneck, and 3x3 grouped convolution mainly used to represent the motion information. So the model is completely trained on the mixed precise using Tensor Core Volta and Turing and NVIDIA Ampere GPU architecture. So this is already a pre-trained model available. So we just added to it by considering a model training over the transfer learning case of our architecture or our data. The advantages of using is that since we are using a real-time scenario, so this model is 3 times faster than the most of the algorithm what we found running without tensor cores. So that's why we have chosen this architecture for our proposed scheme model. So we have considered the coactivity similarity loss and action localization loss what we have already considered previously for this model also. So we tried to consider a variation of the data. So that's why we trained the proposed model with a 400 kinetic database and Thomas 14 for validation actually mainly. So we consider for a single action trimmed video actually for training. So around 17,281 single trimmed action videos are considered for training the model with 400 action classes, and Thomas 14 is composed of 14 different action for validation purpose. So the proposed approach when we try to consider, we got almost 56.03% accuracy as compared to SSN again 60.3, and we got a little bit more accuracy as compared to the previous approach, that is 96.54% accuracy in the proposed model. So this is what exactly we got for result for new architecture. Then we thought of going for temporal granularity actually, so that the action localization can be improved a lot. So for that reason, what exactly we have done is we considered a I3D module, so which is again a 3D type of neural network or CNN model to extract both optical flow and image feature what is available. And this layer is given to LSTM and 1D convolution. So there are multiple layers of LSTMs are there. So mainly we consider 2-layer LSTM here so that we can consider to extract the most important feature what is available in the video. Then we are going for a feature pyramid generation unit, which is mainly giving a deep level of features to be extracted from this video. From there, we are giving a TGC layer, so which is mainly responsible for getting temporal granularity in the convolution process. Further, whatever output we are getting, we are giving it to a action classification network, so which is mainly responsible for recognize or classify different kinds of activity present in the video. So this is actually the key components in our architecture. So there are 3 key components are there. One is feature projection module, where a mainly LSTM, a long short-term memory with 1D convolution is used. And then a hierarchical future pyramid pooling architecture is there. And then a novel temporal granularity converter TGC layer is there. So the first layer of LSTM mainly captures the local spatial dependency, whereas the second layer of LSTM models the long range relationship what we consider. So the pyramid pooling what network we have considered, it has a 5 pyramid levels are there. So with starting from 2304 multiplied by 512 size to 144 to 512 feature space size is there. The pyramid pooling aggregation mainly used for combining the features at different scales actually. So since we are considering to extract features in different scales, we want to consider the combination of all these features in single go. That's why we are using a pyramid pooling aggregation module. And second part is that PPU, or you can say PFGU, progressive feature enhancement unit is there. which is using a dilated convolution rate at 4, 8, 16 different modules are there, which is mainly used to contextual preservation module we are considering. So this is what the result we got when we are going for kinetic 400. We are getting a very good accuracy with a 83.63 at the intersection of union of 0.3, and full model we are getting around 83.63 with 13 Thomas 14 database. Now when we got for different other databases for testing, because we need to test the model with other approaches for publication purpose. So we test it for ActivityNet 1.3 and multi-Thomas database for testing what exactly accuracy we are getting. So we got almost 36.70% accuracy average map in ActivityNet and 35.52 in Thomas multi-Thomas database. So this is the accuracy what we are getting is definitely better than what the existing approach is giving. That's why we corroborate our finding that the proposed approach is giving quite better result as compared to the existing approach. Now, after the same, we thought of exploring the concept of action recognition in dark or low light condition. So as I mentioned that many of the people who are using washroom in the night time, there is a high chance that they usually fall in the night time. So where scene context is very low or rarely visible. And one of the biggest challenges is that if you apply any kind of image enhancement algorithm, most of the scene texture will be lost. And that's why repetitive actions from same person, if it will be there from the video, you can take the data also. You may not be able to take a decision what exactly happening in that video, and that's why it may be very difficult to recognize the action. Now, while going through the literature on this, so as I mentioned, there is very less work has been done in the low light condition. Now, most of the people, what exactly consider is they are using a low light version images with a resonant architecture or delta sampling or different type of process where they are trying to consider to extract the meaningful information from here to create a clear idea about what exactly activity is happening. So initially we thought of going with the architecture, which we are saying action recognition using graph and deep CNN. So the architecture look like this. So what exactly we have done is we have an input sequence of image frames. We have applied a self-calibrated illumination model to enhance the scene content. Now what we found that once we are going for enhancing the information in the image, the textural information is completely lost. So one sequence where textual information is there, but visual information is lost. And the second one, although visual information is there, textual information is lost. So we try to feed both the videos to R2 plus 1D network. So R2 plus 1D network is a resonant network actually. So which is extracting 2 dimension, that is the spatial domain feature, or 1 dimension, that is the temporal domain feature out of it. Now, there is a dark net, another one is a light net. So light net responds to the feature extracted from illuminated or you can say enhanced images. Whereas dark net is mainly responsible for getting the feature from the dark images. Now, we extracted the features and feed it into a temporal graph encoder. So this temporal graph encoder is mainly responsible for merging the information what we are getting it from light stream or you can say dark stream. So this network is trying to merge the information from both the network and feeding it to a neural network classifier to find out what kind of activity is happening. So as you are aware, we are using a R2 plus 1D architecture. So it's a ResNet inspired architecture only, but it's a 3D version of the ResNet. That's why expected that most of the information what exactly you will get is a kind of higher chance of getting a very fine on deep level features. The temporal graph encoder is mainly responsible for utilizing the long range relationship between the frames, both in the light and dark stream, what we are considering. Now, for testing it, what we have done is we consider to train the complete model on a ARID 1 and ARID 1.5 database. So ARID 1 and ARID 1.5 are two action recognition dark database actually. So these are dark video database. So we consider 2287 videos from ARID 1 and 3792 video from ARID 1.5 database. So we have validated the complete model on 672 video of ARID version 1 and 768 videos of ARID 1.5. Further, when we test the model, we found that in top 1 accuracy, we are getting almost 95.869% accuracy in top 1 and 99.878 accuracy in top 5 category. Further, we consider a new approach, which we are saying that bidirectional encoder representation transformer based approach. So this is a modification of the previous approach only. So where multi-level of features are considered. So first we try to preserve the dark level feature. That's why the dark image frame what we consider is first extracted with the information, or you can say we try to extract the features, feed it into a 0DC algorithm with min-max sampling. So where the frames are enhanced, and that's why by min-max sampling, we try to consider few enhanced frame for our analysis and feed it into a R21 plus model. Then GCL to combine the feature from all the features what exactly we are extracting. And then we are feeding it into a attention model or attention mechanism where the features extracted from the GCL, what exactly correlation we found, we try to find a relation between them using attenuation framework, or you can say BERT architecture or bidirectional encoder representation transformer architecture. So these features are then fed into a classification head, that is a neural network classifier, to classify what kind of activity is happening here. So this is the complete model. So we are considering a IEM, image enhancement module, followed by action classification network. So we are considering zero reference deep curve estimation for enhancing the dark video. Further, the enhanced video, what exactly we are getting, we are feeding it to a R2 plus 1D network with GCL followed by BERT architecture to find the relation between the feature, and further a neural network classifier to classify them into different activities. So this is mostly a zero reference deep curve estimation architecture algorithm. So it is considering to fit a gamma curve actually, or zero without training, since it is happening. That's why we are saying it is a zero reference. Deep curve is to say that we are predicting the gamma value so that the image can be enhanced. So here the new thing is that we added with a BERT architecture, so which is composed of key query and take the input from two type attention actually. So we are using a multi-head attention network to find the relation between the features so that it can be properly categorized into different type of actions. So exactly same thing we have done. We have applied over ARID 1 and ARID 1.5 for training and validation on ARID 1 and 1.5. And we found that we are getting a 95.02% top 1 accuracy in the proposed model, whereas in top 5, we are getting 99.64% accuracy. When we are considering a map, we are getting 84.90 top 1 accuracy and 99.32% in top 5 accuracy. So this is what exactly we got from the result as compared to the previously state-of-the-art techniques. And the result says that the proposed approach is quite better as compared to most of the existing techniques. So with this, these are the architecture part exactly we have designed for activity recognition, mainly detecting the faults. These are few references. Thank you. So I'll be happy to take any question if you have anything on this. Over to all of you.
Yeah. So participants, if you are having queries, you can write them in the chat box. Thank you so much, sir, for your insightful talk on activity recognition and all. And you have also shown so many applications and so many recent works you have especially contributed.
So I think there are some questions are there. May I take those questions?
Yes, sir. Yes, sir. Please.
Okay. Okay. Maybe how to know which are the question from my part? Okay.
Yeah. It can be. Yeah, it's just you can just
What
say that.
lightweight architecture, balance, performance, and efficiency, real-time human
No, no,
robot
no, no, not that one, sir. Just look at the site
17,
actually. Yeah,
719. How to
710
handle
and
multiple
790.
overlapping actions in untrimmed videos. Uh, can you confirm what do you mean by multiple overlapping actions? Since
There's
we are
one.
considering mostly that whatever activity is happening due to a particular person, so we are considering that the action is correspond to individual specific. So even though multiple people will be there, we are not considering these are overlapping activity rather than two separate activities happening in the video. So that's why we are not getting this concept of overlapping. Maybe I'm not sure what exactly this question meant by. If can be clarified, I'll be happy.
Yes, sir. There is another question that what does local spatial dependencies and long range temporal relationships mean within feature?
Okay, actually, when we are considering the videos, so there are multiple frames are there. So when we are saying local spatial dependency, we are concentrating mostly on what kind of things happening in a particular image actually or image frames. Whereas when we are considering the video, there are several frames are there. And when we are considering temporal relations, so we are mainly ranging from different time stamp, what are the relation between them. Maybe possible that if a person is eating the food, so there are sequence of images are required to represent the eating action. Like I take a picture while picking the food, then putting it mouth, and this will take almost 5-7 frames actually. Or you can say if you are considering 3-second video, so every second if you are considering 25 frames even, so total 75 frames are there where the consecutive actions are there. So taking a food from the plate to mouth. So this is a complete range of images. So I am trying to consider that this long range temporal relation supposed to be captured by the network. Otherwise, there is no meaning of taking that different activities happening and each activity is represented by multiple frames. So that's why I'm considering temporal relations and spatial dependence both. Any other point? Maybe? What
Yeah.
representations allow model to recognize fine-grained action? Okay, so when we are considering our activity, since we have considered to model to be trained on different large databases, as I mentioned, that when you are considering a human action recognition database of 400 action or Thomas 14 or 14 video actions, so mainly I'm concentrating on different type of activity with a different background condition. Like I mentioned that in a pub, one person is playing the flute or different people are dancing. There are several small activities all been happening in the background. So what we are considering that when we are concentrating some particular action, the large size object what we are concentrating is we are concentrating for that action only, not the small background activity. So these are we are just omitting, or you can say maybe these are considered to be noise. We are pruning initially all these activity. Yes, we can recognize the activity from still images, but most of the work what we concentrated is we are considering only trimmed, untrimmed of videos are there, and we are considering mainly 3D network to represent the actions. That's why we are mostly considering the video case for recognizing the activity, but definitely we can recognize the still frame to recognize or still images to recognize the activity also. Over to you if you have any other point.
I think can we recognize the activity?
Can you repeat again? I am unable to hear you. Sorry.
I think, sir, all questions have been answered. Can we recognize activity by still images?
Yeah, I mentioned that since our case, we are considering most of the model as a 3D model. So 3D model is applicable for videos. So that's why we are concentrating on video database. But definitely still image case also you can go for activity recognition. So there are many algorithms which can be used for still frame for activity recognition. Definitely. But in our case, since we are considering most of the model, what I am considering for feature extraction, they are 3D model of CNN. So that's why our model is mainly concentrating on 3D models, not on the 2D models. So that's why we cannot able to recognize the action from still images in our algorithm. But there are many approaches. We found that those things are a little bit simpler for us. So that's why we have not explored to go for still image for action recognition.
Yeah, I think, sir, there are no other questions. Let us now thank our speaker, Professor Badri Subudi from IIT Jammu. Thank you so much, sir. Once again, on behalf of the Computer Science Department and E&ICT Academy at MNIT Jaipur, would like to thank you for accepting our request, invitation, and delivering a wonderful talk on activity recognition. Thank you so much, sir.
Thanks a lot for inviting me and giving me an opportunity to share my knowledge. Thanks a lot once again.
Thank you, sir. Thank you. We are most welcome.
Thank you. So may I leave the meeting now?
Yes, sir. Yes, sir.
Thanks.
Thank you.
Thanks.